Hi guys, in this experiment we'll be looking at trying to calculate the kinetic friction coefficient. Now, to calculate the kinetic friction coefficient, what we can do is we have our system over here, and we can attach a string to our slider, put it around a pulley, and then hang onto that pulley a set of masses. Okay, so to calculate the kinetic friction coefficient, we need to be able to get our system to be in a dynamic state. So to do that, we have our hanger over here on the right hand side, and what we can do is we can give the system a little bit of a tap. And it should be enough to get over the top of the static friction coefficient. Now, if the system doesn't move, we haven't got enough weight, and we can add some more mass to our system. So here, add one more mass, give the slider a tap, system's not moving, add another weight, give it a tap. See, even though it gave a little bit of a movement, it didn't move, continue to move, and then do the same thing again. So we'll move it back, give it a tap, still not moving, add some more mass, system still not moving, one more, give it a tap, so still not moving, one more, give it a tap. And now when we gave it a tap, we can see that the system has begun to move. Now, if you can see that we can see that it's overcome the static friction coefficient on the left-hand side. So if I take our system, lift it back up, give it a tap, that's sufficient to overcome friction for that region. Now, the reason why we're seeing the system stop at the moment is because the friction coefficient for the first part of this steel plate is slightly lower compared to the friction coefficient for the second part here. So there's a little bit of surface rust that we see on this plate. Alright, so we can perform this experiment for a range of different values here, but now what we've done is we've got a mass of a slider and the mass of a hanger. We can take the hanger with all of its weights and weigh it, and then we can also take the slider here along with its weights and weigh the mass of the slider along with the weights. Now, those two values, we multiply it by gravity, or 9.81 for our system, and then we can calculate the force of friction and the normal force for our systems as well. And then from the friction force and the normal force, we can try to find out the friction coefficient if we plot those two values. Now, we can also perform this experiment by taking an additional mass and placing that additional mass onto the system as follows. Alright, so connect the system up. Put our hanger back on. So we see that this time the system doesn't move because of the higher mass here, and then we can add more mass onto the right hand side, give it a tap, and keep going until we see the system move. Alright, so thanks for watching. I'll see you in the next video. Thank you.